Good evening, everyone. So this is group 2 and our project about an explainable AI model for cassava disease detection. So the previous models have been available, but not explainable like in case. Reason why we chose cassava. Cassava is vital because it's basically a crop that can be eaten before it's processed and even after it's processed, maybe to make posho, the cassava flour. Yeah, so diseases, many diseases try to suppress this cassava, like cassava mosaic, cassava brown streak, and this hinder the quality of the output that can be got when harvesting. So we came up with this model that can help farmers to know what specific disease a specific cassava plant may be like suffering from, like basically using the leaves, you scan the leaf, and from the model can give you the potential disease, maybe cassava mosaic, cassava brown streak, that may be affecting that particular plant from the leaves. Yeah, cassava is actually a crucial crop because actually basically in Uganda, cassava is crucial, and this model is actually going to be helping a lot in the output that can be got. Next slide. The problem was I talked of the reduced quantity. Yeah, so that's the coming up with this model can help like solve that issue, since you can know the diseases that the specific plant is suffering from at an earlier stage. Then the previous models have basically been about different crops, like tomatoes, not basically cassava. Then like the need for an explainable AI model has actually, like, the farmers needed to know what exactly, and an explanation of why that specific disease has been like predicted. Next page. Next slide, please. Yeah, that's the related work is basically about the tomatoes, and then other models using VGG. Yeah, that's it. Thank you. Next presenter, please.
Good evening, everyone. I'm Nabageka Bridget. So, continuing from where my colleague stopped, so where we talked about AI in agriculture. So, at first, talking about AI was being just a research, but now it's being applied practically. So practically, it's being applied, and this helps in disease management, and maybe it has helped in the discovery of more diseases and how the crop will be protected. And so, also talked about transformative potentials. Transformative potentials could include automated disease diagnosis, whereby AI is empowered like deep learning algorithms to quickly identify diseases and then replace them with manual methods. And then we talked of crop monitoring and then precision. Then we have gaps in AI. So AI accuracy often prioritized over interpretability. So many researchers basically have been focusing on how accurate are the results, forgetting that how will it be interpretable, and then making it act like a black box, whereby you can see the disease, but you don't know, does it explain to a farmer well how the disease comes about and how you can prevent it earlier. So lack of standardized evaluation matrices and benchmarks, and then you have underexplored integration of AI models with domain-specific knowledge. Next page. So talking of the contributions, it has helped in our research has helped in the developing of an explainable model. So this helps basically, so it helps in understanding the interpretability. It helps in understanding like how in terms of develop an explainable. Yeah, it explains the model. It explains what causes the disease, how it's caused, how we can prevent it. So that's how our research helps. And then multi-disease detection, it helps in identifying multiple diseases, not only focusing on one disease. But okay, we can focus on one crop, but then you talk of all the diseases that could possibly attack that crop. So for our case, it was cassava. So it can not only detect maybe, let's say, cassava mosaic, but also detects other diseases, and then it explains them and how you can prevent them. And then community impact. Yeah, so our research hopes on like once you come to know that disease on time, you can use it to prevent it, and this can save your entire farm from getting spoiled, from getting affected by that same disease, and then this will help improve on the maybe communities earning and help the farmers also to be well off. Next slide. So you have research objectives and research questions. So one of our research questions is research objective was create a mobile app for farmers to detect cassava diseases using smartphones, and then the question is how to design an easy user interface for farmers with limited tech expertise. So here you take an example like a farmer who needs a simple system to detect, a simple tool to use to detect the disease, and then it explains to him maybe what he needs to take on so that to prevent that disease from happening again. So our app is designed in a way that it's simple, and it has simple things like a menu, and this helps the farmer to easily navigate and use the application. So we also have another objective is clean and organize cassava plant image to prepare them for AI analysis. And then the question is how to optimize image cleaning and organize to improve AI analysis efficiency. And this is basically to help remove like the noise, the standardized lighting, and then to maybe adjust image resolution. And then we have to collect diverse cassava plant image from agriculture databases. And then the question is how to ensure the collected dataset represents various cassava disease detection in the real world. So I'll call upon my next colleague. Take on. Thank you.
Good evening, and this is Makasanji Jonta. I'm going to take you through our research methodology. The picture displays everything that we did throughout our project. We started with obviously collecting the data, then doing exploratory data analysis, data preprocessing, whereby we make the images more useful, and then we remove noise, we do data cleaning and all that. So we had to split our data. We split it into trained data, validation data, test data, and we used the trained data to do the model training. So we trained the model using the RESTnet 50 model architecture, and then after we had to evaluate our model using evaluation methods. And so after, because we wanted to have an explainable AI model, we had to put in the concept of explainability using red as our explainability technique, the one we used. And so we had an explainable AI model. So about the data set we used, we got our data set from Mr. Jonathan Makula, who was a field supervisor, one of the group members. He was to one of our group members. And so the data set he provided, he gave us a link to an online data set. And so the image below shows the contents that was in the data set. We had 5 classes. So we had 4 disease classes and we had 1 health class. We had cassava mosaic, cassava bacterial blight, cassava brown spot, and then cassava green mite as the diseases, and we had cassava health. So the number of images contained in each class are displayed in the table below. So these are, the table below shows our experimental results. The results we got from training. We used stratified care folds to do, we did cross-validation. So we had to train using RESTnet 50 model architecture. And so we had 3 folds, each having 5 epochs. And so we considered the best accuracy out of all the 5 epochs in the 3 folds we had. If you look at the accuracy we had throughout, the best accuracy was 92.14%. So that was our accuracy, and it's the one we took. So model evaluation, we used accuracy to do model evaluation. And so these curves represent two data sets, the validation data set and the training data set. The validation data set was the one that was not the data set that was not seen during training, and then training data set was the data set seen during training. So in each fold, we had accuracy and loss, and then we had three folds. You can see we have fold 1, fold 2, and fold 3, each having accuracy and loss. So these are the results. Of course, we had to integrate our model in a user interface that can be accessible by the farmers, because it was one of our objectives to develop a user interface whereby the farmers can upload their images and then get results. So from the upload page, the farmer inputs the images, and then results page, we see that the farmer uploaded a green mite leaf, and the system was able to detect that the uploaded image is green mite with a confidence of 85%. And still, because we are dealing with explainability, the model still showed the farmer the parts that contributed most to the model's decision. And so the farmer is able to base on the parts that the model or the system highlighted to know why the system had to choose the particular disease. To know that if I have a plant and I have these symptoms, this is green mite, this is mosaic, this is healthy, and so on. So I'm calling upon my next colleague to take on.
Good evening, this is Ziwa Abdurrahman. So, in conclusion, Cassava adaptability and versatility underscores its significance. Then, machine learning models like CNN and SVMs show promise in disease detection, but ensuring their explainability is essential for building trust. Like these models can easily detect the disease, but ensuring explainability will build trust to the users that are to be using them. That's why we are doing explainability. Then addressing interpretability and bias concern is crucial for fair and transparent disease detection across diverse cassava cultivation environments, emphasizing the importance of responsible AI application in agriculture. Then addressing interpretability and bias concerns, whereby after identifying a given disease, it gives you the explanation and then the bias. For example, on the previous slide, where it gives you the heat map of how it easily detected that disease. This will help to improve or emphasize the importance of responsible AI application in agriculture. Next slide, please. Then these are the references where the different links, books where we resourced some information that we used in different parts of our project. The next slide. Then the acknowledgement. Here we acknowledged our university, Makerere University, and then we also acknowledged Dr. Rose, our supervisor, who helped to advise us on different occasions during our project, in that she was helping us on how to tackle different areas of our project. And then we also acknowledged the cassava farmers, who helped us to identify in selecting our project, in that they were advising us on the cassava diseases that were affecting them more, of which they could not understand which is which. And that's all.